Hello and welcome to today's EuroSTAR webinar, Things Could Get Worse, Ideas about Regression Testing with Michael Bolton. So my name is Miriam and I'll be your webinar moderator today. And before I hand you over to Michael, I'd just like to go through a few items. So if you can see the current slide, the Q&A session will take place at the end of the webinar. And as you can see from the slide, there's a dialog box on the right which you can type in your questions. The webinar will also be recorded and you'll be emailed once it is available. So for slides, we will post all slides on the EuroSTAR blog and we'll also email them to you. And we'll do the same with any questions that we don't get to. And for Twitter, then of course Michael Bolton's on Twitter, and if you want to tweet to him during the webinar, please make sure to use the hashtag ESConfs and we will get back to you afterwards. So I'll just hand you over to Michael now. Good afternoon, Michael.
Afternoon, but it's morning here. There we go. It's morning here in Toronto, and here we are. I've now pushed everything around on my screen, and here we go. So let's start. Who am I? I am this guy. I'm Michael Bolton. There's lots of different ways to contact me. Why did I pick this extremely odd picture? Well, I was just in China, and I was standing on the Great Wall. You have no idea from the pictures what an amazing thing the Great Wall is, and how enormous it is, how far it goes. The pictures don't really convey that very well. The other thing they don't convey is just how steep it is. There you see me standing straight up, and I thought of this picture because what I thought about was backsliding. The idea of things getting worse, the idea of things regressing. And when you're on a steep slope like this, like the slopes that we have in software development, you tend to have a good chance that backsliding will happen. The other thing that I was reminded of as I was preparing this talk was that I usually would do a talk up in my office, but the way things are moving around, the router is downstairs. I wanted a wired connection, so I just want to prepare you for a couple of things you might hear since I'm doing this from my home. You might meet this guy. You might meet the courier. If he shows up, then the dog will go berserk. That's the dog on the right, by the way. The other dog is my daughter Ariel. It's always good to start a webinar with a picture of a handsome guy, a cute little girl, and a dog. All right, things could get worse. In fact, my brother-in-law, Greg, lives in Moscow, and when he moved to Moscow, he heard about this, well, it's a joke, this Russian optimist, the idea of the Russian optimist. Russian optimist, when you say to a Russian optimist, things couldn't possibly get any worse, the Russian optimist says, oh, come on, things could get worse. So that's what we're going to talk about today, things getting worse. There are four ideas that tend to float around. I try to listen to people speaking about things, and when I do, I hear these four different kinds of ideas about regression testing. And they overlap to some degree, but they also contradict each other somewhat. First one is, any test that we performed before, that's a regression test. If we do a test again, if we repeat a test, some people say that's what a regression test is. Another school of thought says that regression tests are sets of automated checks that we periodically and repeatedly run. So we run a whole bunch of checks. That's kind of the same as a test that we performed before, but I also want to underscore the difference between testing and checking, something we'll get to a little bit later on. Another concept of regression testing is any testing that we perform after some change has happened to the product. And that kind of overlaps with the other two, but not always. Sometimes we repeat tests. Even though a change hasn't happened, sometimes we do some performance of a test after a change, but sometimes we haven't performed that test before. So the definition of regression testing that I kind of like best is testing to probe whether quality has actually got worse. And in particular, I want to identify the difference between that and the first definition that I proposed. When we look at them together, these are the most, in my experience, the most common notions that people have, and they overlap and they slip into one another, but they're not the same. A repeated test might not actually show that quality has got worse. Quality might have got worse in a way that an old test doesn't identify. And a test that shows that quality has got worse, that might itself be a new test. It might be a test that we've never performed before. So let's see if we can untangle these and sort these things out. There is one other thing I'd like to mention, though, and that is, well, I remember starting in about 1994, 1995, I started hearing this, and I keep hearing it every now and again, so I wanted to underscore it. I keep hearing people say, after something happens or after a change has occurred, well, we want to regress the build. Well, what does regress mean? It means to move backwards. What does regression mean? It means any kind of backwards movement, any kind of backsliding, moving to a former state, a relapse or reversion to something. So here's one thing. Regress the build means make the build go worse. Make the build get worse. Please don't say that. Please don't say I'm going to regress the build. You know, yes, it is a pedantic point, but at the same time, it's very important, I think, for us to really think hard about what we're doing and what we're talking about. And whenever I hear somebody say regress the build, it suggests to me that they're not really thinking about what words mean. Some people say, oh, it's just a matter of semantics. Sorry, semantics are really important because semantics is the study of what we actually mean. And I think we pay a little less attention to that than we might. Okay, so what do we got? Here's a hypothesis about regression testing, that regression, backsliding, is an important risk to the product and to the project. That's the first premise. Second premise is that programmers are working really fast, and that is a truism, it seems today, that programmers are always under severe time pressure to get stuff done, especially in agile environments, and so there's a danger of stuff getting broken. Another premise is that stuff that used to work, if it doesn't work now, that's pretty embarrassing. And if it used to work and then it got broken and then it got fixed and now it's broken again, that's really embarrassing. Therefore, goes this hypothesis, we should focus the bulk of our attention on tests that we performed before, on automated checks, and on testing after changes. Now, just to check this out, I went to Wikipedia to see what Wikipedia has to say about this. What do the commons say about regression testing? What Wikipedia says is that the intent of regression testing is to ensure that a change, such as a bug fix, did not introduce new faults. That sort of is in contradiction to the idea that a bug fix might have caused quality to become worse, in that you can introduce new faults without old problems resurfacing. So that's kind of confusing. We've got to untangle that. One of the main reasons for regression testing, says Wikipedia, is to determine whether a change in one part of the software affects other parts of the software. Well, that's true, except sometimes a change in one part of the software can affect other parts of the software beneficially. So that's, again, in contradiction to the idea of quality getting worse. Another notion is that regression testing can be used to test a system efficiently by systematically selecting the appropriate minimum set of tests needed to adequately cover a particular change. Well, that's very interesting to me, because it seems that if we were to think that way, then we would perhaps lose some opportunities that we could take advantage of, especially in reference to automated checks. Why would we want to systematically select an appropriate minimum set of tests? That seems to me based on the premise that testing is expensive and slow, and that all testing must be expensive and slow. On the other hand, maybe we could think in different kinds of terms. Maybe we could use automation to make a large number of tests very cheap. Another question that comes to mind is, what is the appropriate minimum set of tests? How do we define appropriateness, and how do we define what's an appropriate minimum? How do we think about adequate coverage? You know, when I think about coverage, I think about an iceberg. When we think about an iceberg, one thing that we realize is that what we can see about the iceberg is not everything that we could know about it. When we think about all the risks that could befall a product, the ones that we know about are really like the tip of the iceberg, the ones that we can see. There are more risks than that, of course. There's all the risks that we could imagine. And then on top of that, in this vast ocean, there are also all the risks that there are. And we are limited by our imaginations when it comes to risk. We're limited by our experiences and by our models. Similarly, the iceberg metaphor applies to tests too. When we think of the suite of tests that we will run through the course of the project, the tests that we repeat are like the tip of the iceberg. They're the bit that we can always see. They're the bit that we're always able to train our eyes on. But there's another big bulk of stuff, which is the tests that we have performed before. And there's another vast ocean full of other icebergs, tsunamis, reefs, other ships, other projects, things that we could bump into. And that's a big complex space. So one of the things to keep in mind about any kind of testing, not just regression testing, is that we're always sampling. We're always doing less than is within the scope of what we could do. We're always doing a subset of that. All right, so let's look at these things in a little bit more depth. Let's focus first of all on the any test that we performed before notion. And ask, is it the primary purpose of testing to make sure that the product still works? Is it the primary purpose of testing to confirm what we believe used to be true about the product and what we hope is still true? Or is it the case that we want to learn all that we can about the product? If the purpose of testing is to reveal new information, the question we have to ask ourselves is, why would we repeat a test that we performed before? Isn't that looking at the past? So one of the questions that we have to ask ourselves is, how much time should we spend looking in the rearview mirror? How much time should we spend on things that we believe we already know? And what are the motivations for that? Well, we'll get to some of that later on. One way we could do that, a lot of people propose, is to create a suite of automated checks. Now, I'd like to be specific. Maybe there's some people out there who haven't considered the difference between checking and testing. A check has three elements to it. A check is, first of all, an observation of the product, doing something. So, check is an observation of the product, typically in the form of asking the product to do something, providing it with some inputs, asking it to go through some behavior. And then we get to the second part, which is a decision rule. The decision rule returns a bit, yes or no, true or false, pass or fail, 1 or 0, green or red. The thing that makes a check is the idea that both the observation and the decision rule can be applied non-sapiently, that is, without human judgment or wisdom. A check is like an atom of a test. It's a little itty-bitty microscopic assertion. It's the smallest atom of testing we can look at, in which we make an assertion, true or false, yes or no, pass or fail. Does this input produce this output? So a check can be performed either by a machine that can't think, but which can execute lots of observations and lots of decision rules very quickly, or it can be applied by a human. A check can be performed by a human who's been instructed not to think. That is, a sufficiently disengaged human can also do checking if we essentially automate the human, if we give the human some observation to make and some set of operations to perform and a rule to apply. And if the human doesn't have to apply judgment or wisdom to that, the human is doing a check. Now, checks are fantastically good for certain kinds of testing issues. Decidable propositions, things that will give us a one-bit answer. A check is very good because the check has to be programmed in advance. A check can be very good for risks that we can anticipate. It can be very good for confirming things that we can anticipate to be true or false, and where we have some element of risk associated with that, we can perform a check. We can program a check and have a machine perform the check and then analyze the check afterwards to see if the function is behaving as we thought it should. Checks are great for rapid execution. They can be performed extremely quickly at machine speeds. They're very good for finding certain kinds of bugs, especially functional bugs in the product, where we have a straightforward set of inputs and an observable output or set of outputs that we can compare against some oracle. And the oracle in this case has a specific kind of result that can be expressed quite precisely. So checks are great for functional correctness, and they are especially wonderful in my experience and observation for the lowest levels of the product, the bits of the product where programmers are working most closely with the actual functions in the product, where we're looking at straightforward transformations of one string into another, one set of values into another. Checks, on the other hand, may not be so great for questions that are more open-ended, qualitative kinds of questions, which we'll address in a little while. Checks aren't that great for risks that we didn't anticipate, since a check has to be programmed in advance and designed in advance. If a check reveals something that we didn't anticipate, it's a matter of luck. And somehow, sometimes we get an observation like the whole suite failed to complete or the whole system crashed. But it's also quite easy for a whole suite of checks to run without finding certain kinds of problems. Checks are not so great for exploration. Now, it's interesting because as we're exploring, we are doing checking all the time. But it's being done in our heads. It's being done largely unconsciously. It's a lot of checking that happens as we go is a sort of instant kind of observation and evaluation that we do so quickly that it gets immediately dismissed from our consciousness if we were ever conscious of it at all. What happens more often during exploration is that our oracles are applied in the moment. Obviously, we can prepare ourselves with some kinds of oracles beforehand. But during exploration, one of the advantages that humans have over mechanical checking is that humans can spot a new problem. They can make conjectures. They can wonder what if. They can change their behavior as they go. Checks are very good for rapid execution, but the development of checks is slower. Checks must be explained to a person or to a machine. They must be expressed in terms of written English or program code. And checks aren't so very good for things where we require a more reflective kind of evaluation of it. The same kind of qualitative aspects of a program that are not functional aspects necessarily, what Kem Kainer would call parafunctional aspects, but which require considerably more judgment and more wisdom, more experience, more knowledge of the business domain and that sort of thing. An issue is distinct in our lexicon in the rapid software testing course that James Bach and I teach. An issue is distinct from a bug. Here's the distinction. A bug is anything that threatens the value of the product. A bug is something that threatens directly the value of the product. An error in the program, a fault that would cause some person to experience diminished value. An issue is something a little bit different for us. For us, an issue is anything that threatens the value of the testing, or anything that threatens the value of the project, or anything that threatens the value of the business. As testers, most of the time, the issues that we find are going to tend to focus on testing. But issues are anything that slows down the project, slows down the testing, makes testing harder or slower. Now, there's one kind of issue that developing checks can identify quite nicely, and that is testability problems. One of the things that I've experienced when I've developed a large suite of checks for products, mostly in the financial sector, is that in developing those checks, I find out a lot of stuff about how easy it is to know the internals of this program, how easy it is to write programs that will check the program. And what I've experienced is that checking is very good for that. But in a way, sometimes that felt kind of strange to me, in that what I was finding was it was more difficult to check the product, but I found that my focus on checking the product and the things that made checking harder or slower were focused on the checking itself. And so I had to wrestle quite a bit with a dilemma. Is the amount of checking that I'm trying to do on this project interfering with my testing of it? So certain kinds of issues in development of checks become immediately apparent, like how hard it is to check the program, and indeed, in my experience, checkability is something that is often neglected. And a more checkable program is, on a certain level, a more testable program, in that really good checking allows us to do splendid really good checking allows us to do splendid amounts of microtesting, little tests that we might encounter when we were doing higher level human testing, interactive testing with the product. But there are lots of other kinds of testability issues that checking and the development of checks doesn't tell us about. Because computers are only really logic machines in a formal logic kind of sense, computers don't look into nuances of various quality criteria that we'll talk about in a few moments. I'm thinking primarily in terms of usability, security, compatibility, supportability, and checking doesn't tend to do that very well. So, where can we go from here? One of the things that's important for us to do when we're considering regression checking is to keep in mind the idea that when a check passes, it doesn't mean that the product is good. It doesn't mean that everything is okay. What it means is we didn't detect anything that might be a problem, that was anticipated as being a problem. So sometimes people equate pass with no problem, but I think it would be a better idea for us to think of a pass in a check as no problem detected. When a check fails, what it usually means is that we, or our automaton detected something that might be a problem. So a passing check is a kind of a rumor of success, and a failing check is kind of a rumor of failure. But checks don't really do that, as Doug Hoffman is fond of pointing out. Tests don't really pass or fail, and checks certainly don't. A skilled tester focuses on a much more fundamental and much more important question to my mind, which is this question. Is there a problem here? And that's one thing that checking isn't very good at, alas. So what checking is good for is detecting low-level functional problems. What checking is much harder to do, it's much harder to do this with a check. What checking is not so good at is determining things that are outside of the scope, the immediate scope of the check, in terms of whether there's a problem or no problem. The other day on Twitter, my pals Earl Everett and George Dinwiddie were in a conversation. George asked, if a test has never passed before, how can it be called a regression test? Well, you could think of it in terms of a test or a check that hasn't passed yet. But Earl raised a very interesting point, which is that if the test didn't pass before, maybe it still shouldn't pass. So this is interesting because it seems to me that regression checks are what Kem Kainer sometimes calls change detectors. That is, they detect a change in the product with respect to the thing that the check checks. But they do not really pass or fail in the sense of assessing being any kind of qualitative assessment. Pass or fail is really a mapping of logic from 1 to 0, yes or no, true or false, into this more qualitative idea, pass or fail, and we need to be careful about making that distinction. I think it might be a better idea for us to ask, what can we learn from this test? And what else can we learn? And that's the principal difference between a check and a test. And a check has a very predetermined kind of set of results. But a test is different. A test, an inquiry, an investigation, a question, open-ended and raised by a human, is something that a machine can't handle very well. So checks help us to determine whether the product has changed state with respect to the checks, but they don't necessarily probe how things might have got worse outside the scope of those checks. Now, a lot of people believe that I don't like checking, or that I don't believe in checking. It's not that I don't like checking, but I want to honor testing. Testing dominates checking. That is to say, checking is a little circle inside the much bigger circle of testing. Nonetheless, checks can be very important. If we don't produce regression checks, there's a chance that we might delay discovery of certain kinds of low-level functional problems that will lay buried and which will percolate up into either problems as we're testing later on, in which case we have to investigate and report that problems, which costs us time that might be better spent on obtaining coverage. Or, much worse, we may not discover those problems at all and they may get out into the field. If we don't do enough checking, we may not have enough time to vary our tests. That is to say, and it's an argument that a lot of the Agilistas make, that really good checking gives us more time to do exploratory testing, to look at the program from a more testerly kind of perspective rather than a checking perspective. And there's something to that argument. I think it's a very important thing to keep in mind as we make choices about where we're going to focus our efforts. It's pretty clear to me that checks are dandy for testing at the application programming interface level. So if we, for example, decide to do all of our evaluation of an API interactively, we're probably going to take a lot of time and miss a lot of stuff when we can get the machine to throw lots of data at the API. So checking is splendid for that, and since more and more pieces of software are being developed as components to other pieces of software, interacting with other pieces of software, then checking of the API and even using automation in an exploratory way is a great thing to do. I referred a little bit earlier to the notion of bug investigation and reporting. In session-based test management, one of the measurements that we make is we make a measurement of how much time is spent on charter test design and execution, and contrast that with how much time is spent on bug investigation and reporting and setup. The latter two things, bug investigation and reporting and setup, interrupt testing. If you think in terms of the product space as a checkered board that we have to cover, each square on that board takes us some time to cover, and we can move from square to square to square, but as soon as we find a problem in a square, we have to stop at that square and investigate and report it, and that causes us to stop moving. So one of the advantages of low-level regression tests, regression checks, as performed by the programmers especially, or at way down low at the unit level, maybe percolating up to the interface level, is that they can help save us time by finding problems when those problems are more visible, closer to the actual code, when they're easier to analyze, and that can reduce investigation and reporting time. So if we don't do enough checking, then there's a chance that that will increase. Another thing that will happen, of course, if we're not doing low-level checking, is that the feedback loop gets longer. Since the programmers themselves are producing and performing low-level checks, certainly in an Agile model, the idea is that they get feedback instantly. They get feedback quickly, right away, and that's a good thing. On the other hand, if we tilt it the other way and we go to an excessive focus on regression checks, what we may do is we may suppress the discovery of new risks. We get, and I've had this experience of getting all wrapped up in trying to create regression checks and over again missing important problems in the product because I was trying to look at the product from the perspective of a machine, from a functional perspective rather than from a parafunctional perspective. And that led to me missing for a while some pretty important problems and pretty important bugs in the product. So we have to be very careful about not focusing over much or overly long on checking if it's going to compromise our ability to see new risks and new problems. Another thing that checking doesn't do for us very well at all is it doesn't help us to identify new usage modes for the program. And on many occasions when testing a product, I've discovered new ways of using it, unanticipated ways of obtaining value from the product, and things that aren't inherent in the design but are emergent from the design. And too much focus on checking can distract us from that sort of stuff. In addition, one of the things that I, as a tester, really love to do is I really love to explore what people actually do with the product, the operations of the product rather than the functions of it, the functions being the straightforward mathematical transformations that happen inside the program. You do this and this happens. Yes, you can do this and this happens, but how do people actually use the product? How do they obtain value from it? What do they do to get their work done? And so in addition to being enjoyable, that of course is centered around how people actually value the product. Another thing that checks can tend to do is that they may inhibit us from varying our patterns, varying our behavior in certain kinds of ways. I see very few suites of automated checks in which the automated suite changes its mind, goes back on stuff, gets interrupted, doesn't, or where it makes decisions based on a whim, where the phone rings or the courier arrives at the front door and the dog starts to bark. You don't see those sorts of things in automated checks. And where automated checks are really important, at the same time, it's also important for us to model the user's task and to pay attention to the qualitative aspects of the product. So, interactive, varied, perhaps scenario-based or checklisted, but not so heavily scripted tests, that is, testing and interaction with the product, I think remains tremendously important in as we move on. We need not only to make sure that the product is functionally correct, but we need to gain experience with it. We need to experiment with it. We need to play. We need to, a word that James Bach has adopted from a book called Free Play, we need to galumph through the product. We need to do overly elaborate and varying things in order to make discoveries about the product and to use it in non-straightforward ways, just as real people do. If we look at the quality criteria that are laid out in the heuristic test strategy model, checking is really good for certain kinds of things. It's fantastic for capability, the basic kind of functional checks. It's pretty good for reliability. There's a lot of great things that we can do, especially in terms of high-volume automated testing to take advantage of checking. For usability, for charisma, an idea that came to us from Richard Edgren in Sweden. Charisma is the general kind of likability of the product. Its capacity to delight us, its capacity to do things in an elegant way. Those things can't be checked, they must be tested. Security. Well, there's certain kinds of checks that we can do for security, things like input constraint attacks, high volume stochastic kinds of tests we can do to probe security. But there are other things that we need to do in security as well. We really need to test inventively and sapiently for security problems. Scalability, performance, installability, a lot of scripting can help with that, but at the same time we need to do some testing as well. We need also to make sure that the design and the analysis of checks is important to us as well. All these things that we have listed remind me of an incident that happened a little while ago. A tester came to me after class, and as part of the class there's a day of consulting that I typically offer. And one of the testers in our little session the next day came up to me and she pointed out that she wanted to look at some of the checks that she was running, but we couldn't do that. The reason we couldn't do that is because the checks have been getting longer and longer and longer and longer. And I said, well, have you told this to people? Have you showed people this? And she said, well, I kind of tell them about it, but you know, today's the first day it's taken this long. So it seemed to me when I talked to her that this problem had been getting worse and worse and worse for a good old long time. And so one of the things I'd like to show you now is I'd like to show you what I suggested that she might do. What you might do with your checks is to remind yourself that checks return a whole bunch of data if you ask them to. And when I was doing some checking work in a bank, one of the things that I observed was, in addition to the outcomes of the checks, was that the return value for this function in Perl's www mechanize library, when you sent out something on the web, the return value that you got would be oriented, or would be the length of time that it had taken for the round trip transaction. So let's have a wee look at that and see what we could do. These in the row that you see here are results of the test, a 1 or a 0, of the check rather, a 1 or a 0, a true or false, yes or no. These are the timings of the round trip for the check. And what I've got set up here is something that Edward Tufte calls a spark line. It's a little tiny piece of data that shows you a couple of different things at once. And this is a very primitive implementation of a spark line. It's only a two-dimensional thing, but it shows you two different things. It shows you at the same time whether the check passed or failed, whether it returned a 1 or a 0, and it also shows you the amount of time that it took for the check. And one of the things that we can do is that we can put a whole series of these together over the weeks of the project, and I've got them laid out here, week 2, week 3, week 4, and so on, and we can watch various kinds of progress. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, let's go back to the beginning again and do that even more quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see, just letting your eyeball look, that several of the checks, ones near the top in particular, are tending to take longer. Another thing, if you soften your focus, is that you can see certain checks flashing on and off. Test number 17 there has this pattern of great variability to it. You can also see with your eyeball kind of overall progress and then a kind of sudden crisis right here around week 5 or week 6. So one of the things that is worth doing with regression testing, it seems to me, is to track progress over time and to visualize some of those different forms of progression. If you've never attended Edward Tufte's one-day class on data presentation and data visualization, I urge you to do that. And I haven't given him credit here. I really, I've missed doing that. T-U-F-T-E, Edward Tufte is the name. And that's one of the things that we could do, I think, to make our regression testing more powerful. The other thing I want to bring up in this conversation is the question of whether regression is really the biggest risk. In the late 1990s, the early 2000s maybe, one of the lost conferences focused on regression. And in a decidedly non-scientific straw poll, nonetheless, a little bit of just quick thumbnail data gathering, somebody asked, what percentage of problems that you see in the final product are regression problems? And the high estimate was 15%, the low estimate was 6%. So that's kind of interesting. That meant that 94 to 85% of the problems were not regression problems, that they were new problems. Now, many of the mechanisms we already have in Agile shops test-driven development, unit tests, include regression checks. Pairing, that is a control. It's not a regression checking as such. It's more like regression testing, but it's a form of control on regression. Strong configuration management, build version control, continuous integration, all those things are very strongly focused on automated checks. So how serious a risk is regression in those kinds of circumstances? Wouldn't it be a good idea to expand our search and recognize the value that these checks are already delivering for us and extending our testing into new areas as change happens during the project? In addition, if we see a pattern of regression checking producing large numbers of regressions or showing large numbers of regressions, isn't that a symptom of a bigger problem? Many regression problems are actually symptoms. If you see a consistent pattern of regression, maybe any given check or even any particular set of checks are not your biggest problem. Maybe the issue is that you've got a regression-friendly environment. You've got buildings that are fire traps, or you have a bunch of arsonists running around. I've noticed, too, that a lot of people talk about regression testing and regression checking in a very sort of emotional kind of way. I don't want to downplay that. I don't want to gainsay it because I think emotions are incredibly important in testing as signals into the things about which we may have very legitimate and very important kinds of concerns. Why are we afraid of regression testing? Or of regression problems, rather. We like regression testing because we're afraid of regression problems. Why are we afraid of that? Well, a clue for me came from the idea that programmers are going so fast that the risk of regression is a big risk. But I suspect that regression testing and regression checking are not really great ways of addressing that issue. If the issue is that you're going too fast, you're going too fast. And maybe it might be a good idea to slow down, or at least to reduce the conditions that would lead to problems. After all, testing really is like the goalie. Testing for regression certainly is like that. Even on a great team, the best goaltender in the world will miss a shot every now and again. The problem happens when we've got a weak set of defenses, when the goalie is being peppered with more shots, more balls than he can handle. So not even great goaltending can make up for a weak defense. So what does regression testing cost us? That's the next question. And what does testing overall cost us? If we want to evaluate our testing strategy, it's useful to think in terms of some of the costs that we've got and comparing those costs in various kinds of scenarios. Design time. How much time does it take to design a test or a check? How much time does it take to develop it, to maintain it, to preserve and transfer the information so that the other people can take advantage of it? One issue that I see in a lot of places is that there's so many regression checks and tests running that people no longer can tell whether they're relevant or whether they're useful. Excuse me. At one point, James Bach went into an organization that boasted that, this is in the old days when test automation was a big deal, they had 1,600 automated tests that they ran on every build. James renamed the application being tested and discovered that 400 of the tests still passed. So clearly there's some kind of knowledge problem associated with that, in that the tests weren't working and nobody knew about it. How much does testing cost us in terms of equipment cost, setup cost, execution costs? Well, when we look at execution costs, automated regression checks tend to be a pretty big win because they go so quickly. But there's also development and maintenance and transfer costs associated with those things. Similarly, when we look at exploratory regression tests, the amount of time they can take to develop it can be quite minimal, very little. At the same time, though, transfer costs can be quite high because we have to either train people on how to use a product or give them experience in it. And execution costs can be a good deal longer for certain kinds of problems. The point is that in any form of testing that we do, we're always looking at trade-offs, we're always looking at choices. And no matter what choice we make, we always incur an opportunity cost. Opportunity cost being the cost of doing stuff that closes the door on our capacity to do other stuff. That's what opportunity cost is about. So let's go back a little bit and review the story of testing here. To test is really to build three stories. A story about the status of the product, about how it works, how it doesn't work, how it fails, how it might fail. A story about how we tested it, and that is how we set it up, how we operated it, how we observed it and evaluated it, and about what we haven't been able to get to yet and what we're not going to get to at all. The reason that we break testing down into these three levels of stories is because to tell a story about the product, we need to give that story some credibility and some authority, and that means that we need to have that level 2 story. But the level 2 story itself also needs a warrant. And so I want to emphasize how important it is to recognize that we're constructing a story of our testing, that we're making choices as we go along about where we're going to focus our efforts. What we need, what we recommend, things that make testing harder or slower. And if we're going to understand and do regression testing really well, we have to understand what the risks, the costs, the benefits, the value of each element of strategy might be. So let's have a look at this. Wikipedia says the intent of regression testing is to ensure that a change, such as a bug fix, did not introduce new faults. Well, that's true. It's also true that the intent of regression testing is to investigate whether the fix addressed the general instance of the problem or just the specific. And it seems to me that while we can add a lot of variation to the checks automatically, we still need to do quite a bit of testing around a problem after we've done a bug fix. Also to investigate whether there are faults that we missed in that area. So that's a refinement of the Wikipedia notion. Another main reason for regression testing is to determine whether a change in one part of the software affects the other parts of the software. And I think that's something that must be explored. It's relatively difficult to check that on its own. And we have to add exploration to the design of our checks. We also have to learn about the relationship between the software. And we also have to see changes in other things affect the system and not just changes in the part that we're focused on. Regression testing can be used to test a system by systematically selecting the appropriate minimum set of tests needed to adequately cover a particular change. But it's also to question the whole idea of the appropriate minimum number of tests and to question our notion of adequate coverage. And we can also use regression testing to increase the ways in which we could observe the product. How do you systematically select, though? That's an interesting question, because at Quarterdeck we used to mark stuff for regression, but I don't think we ever had a coherent set of motivations for that. It was just a kind of feeling. Well, a couple of people have done some good work in terms of identifying how to make choices about regression tests. Karen Johnson, our colleague, proposes RC, RC, RC. Focus on the recent. What's changed recently? What's changed lately? When we choose things for regression, what is a core test? What's a core function of the product? What's common? What's critical? What needs to work in the product? What's the really important stuff there? Risk. Where is there a great threat to value? Where is there complexity in the code, high levels of interaction, brittleness, things where there's a high chance of us not understanding what's going on? Configuration sensitivity. Karen, in her article on this subject, points out, and it's a wonderful point, that things where there's a high capacity for variation, like configuration stuff, is a good idea to it's a good idea to check that sort of stuff, because that's where complexity and subtle bugs tend to hang out. Stuff that's repaired, stuff that just got fixed, a nice heuristic for choosing or upping the importance of that area in regression testing. It adds some focus to our testing by asking, did it really get fixed, or did it break something else? And there are certain areas of the product and certain areas of all products, and it must be said, unfortunate but true, but there are certain people whose work chronically has problems, and we had some of those at Quarterdeck in the good old days. We had some people who tended to be a little less careful than other people, and we had certain patterns of problems. So an important thing to keep track of, I think, as we consider regression testing, is to consider the risk of areas that chronically have certain kinds of problems, and that requires the skill of factoring. It requires the skill of identifying elements of the product structure, of its functions, of certain kinds of data issues, interface issues, and those are important things to look for. Now, we could also add more R's and RC's. We could add randomized for high volume, high speed automated checks. But watch out, because with a high speed automated check, you also need a precise and high speed oracle. If you don't do that, then you have to do correspondingly more analysis of the data afterwards. Now, that's not necessarily a bad thing, because that can be done in a very exploratory kind of way, assisted by tools, parsers and pattern search programs and visualizations and that sort of thing. But watch out if you lean on checks exclusively for your regression strategy, because you will eventually run into the oracle problem, the problem where oracles are heuristic, context dependent. Confusing areas, stuff that has, especially in the past, received a lot of disagreement, a lot of confusion. Stuff that is rich for regression tests. My favorite way of doing it is to get the checks done and then to try to go through as rich a scenario as I possibly can. Kem Kainer and Hans Buwalda, that's B-U-W-A-L-D, Hans Buwalda, talk about respectively scenario testing and soap opera testing as a way of adding elaboration and fun to your tests. And compelling. My colleague Fiona Charles talks about questions raised in Parliament, or things that get you onto the front page of the business section of the newspaper. Distinct from reasons to do regression testing, it's, I think, a good idea to consider reasons why it might be a good idea to repeat or not to repeat tests. And James Bach and I talk about this in the rapid testing class. There's a list here that you can see in the URL at the bottom of the screen. Old tests get new power when the product changes. Some tests take repetition to reveal bugs. A bug is not always exposed by the first run of the test or the check, and so it's a good idea sometimes to repeat tests and to do things in what might seem like a needlessly overly elaborate way. Retry. It's a good idea to repeat a test when there's reason to believe that you're going to see something different, and that's always true. It's always true that humans will see different things when they run tests at different times. changing something about the test such that one observer might say, oh, that's the same test, and another observer might say, that's a different test. That's a valid reason for repetition. Benchmarking requires repetition in order to track progress and change over time. If a test is vitally important, we might choose to repeat it, even though we don't have any particular belief that it's going to expose a problem. We run the test because it's so darned important that we've got to just be absolutely sure. We repeat a test if we're mandated to do that. If the authorities or if a manager tells us to repeat a test, then that's a legitimate reason to repeat a test. If it's cheap, if it's inexpensive to run a test, why not do that? Why not repeat it? And indeed, it might be cheaper to run an entire suite of tests than to select the 10 that you're actually interested in, the handful that you might be interested in out of a big suite. It's automation. Let it run the whole thing. Some tests might provide all the coverage you want to provide, and you might make a decision that that's good enough, and so you repeat those tests rather than running new tests. I don't really like that idea very much. I believe that we should always be trying to expand our notions of coverage, but sometimes it's reasonable to repeat a test when you believe that a test covers a particular risk sufficiently. So I'm going to now revisit the original regression testing hypothesis. Regression is an important project in Project Risk, but there are other important risks. And so rather than merely repeating our tests, we should also look for regression in non-repeating ways. Programmers are working so fast that there's a danger of breaking stuff. Well, let's pay attention to what our regression tests might be telling us. If there's a pattern of regression, maybe the programmers are working too quickly, not carefully enough, not closely enough with each other. Maybe there's too much coupling or too much interdependency. Now, we've got to be careful about this as testers because we don't run the project. We don't manage the programmers. And so it's cool for us to identify the risks, but we have to be careful about being sure about who should do what, especially if we haven't been programmers, and many of us testers have not. What's interesting is I seem to remember original talk about XP putting more emphasis on this stuff, and I think it'd be a good idea to revisit those great ideas that were in the original XP talk. Well, it's embarrassing to break stuff that used to work or that's been fixed once and then is broken again, but having bugs that we never noticed at all is also embarrassing. And therefore, says the hypothesis, we should focus attention on checks that we've performed before, automated checks, testing after changes, but we should also focus on performing new tests that extends our coverage, that allows us to understand new problems and encounter new problems that are new to us, but that might have been there all along. So we have a bunch of strategy ideas that we have to think about. And like all testing, regression testing requires choices. We might choose to focus on checking, think about how that might have a positive influence or a negative influence on our testing. We might choose to focus on passing checks, but we might also like to think about checks that trigger new questions. We might like to focus on the numbers of checks, but since checks don't detect certain kinds of problems, we might also want to think in terms of increasing our test coverage, not just our checking coverage, but our testing coverage. We might want to notice problems about regression, but we might want to notice general problems. We might want to detect regression. We might want to prevent it. We might want to develop more quickly, but we might also want to develop more reliably, and maybe we might want to do that at the expense of some speed. We might want to focus on making sure that our checks are passing, but we also might want to focus on making sure that we understand the product better. And checks can help with some dimensions of that and not with others. We might want to look for bugs that we anticipate, test to search, but we might also test to learn, to try to expand our ideas about the product and new risk ideas. If you've seen one of my talks before, you might have seen this passage. But I think it's a really important focus for us to think about, a really important thing for us to think about, which is that repeatability in software testing is not as big a deal as adaptability is. With a computer program, when we're testing computer software, repeatability is an issue. But repeatability is something that computers are very good at. Programs tend to be fairly deterministic. What we need, I think, to probe more for is adaptability. Something that is, I think, perhaps downplayed a little bit more than we might. We need to be able to make sure that our software deals with a complex and very human world where people do unexpected things, where they make mistakes, and where machines are fantastic aids to us, but where machines can't replace the checking, or replace the need that we have for testing. Machines that check can do so very well and can be very helpful, but they can't necessarily test. So, to sum up, we need to sort out in our heads the difference between regression and repetition, between regression tests, regression checks, between doing things over and looking for problems. We need to think of regression testing as a kind of last resort, something that will save us from a lack of knowledge, but fallibly, and it's no compensation for doing development. And in fact, observing patterns in regression testing can help to inform choices about development. We need to think about what our regression tests tell us, not just about particular bugs, but also about the development process and how we might prevent regression more quickly, more reliably. Think both checks and tests. Think about cost and value, and focus on adaptability and not just repeatability. And that is the end. Thank you very much. This is my contact info, Michael Bolton, my email address, my website, my Twitter ID. Don't bother with Facebook, and don't bother with LinkedIn either. Gee, everybody still there?
Great, Michael. Everybody is still here, so I'll just take back over and we can start with the questions. So if anybody wants to ask a question, now is your time to do so. So, right, let's see what we have. Now, thank you, Michael. That was a marathon presentation session. Now, let's see. No. Okay, we have a question from, I hope I pronounce your name right, it's Sandeepa Bera. How can we plan regression testing in agile projects, as there are a lot of changes that come in very fast?
How can we plan regression testing? Yes. Well, you know, one of the things that has bothered me for a long time is a confusion and emphasis on planning versus preparation. If you know how to test, if you study testing, if you practice testing, you can be prepared to test. If you're prepared to test, then planning isn't that important. You do not have to develop a detailed plan in advance. After all, one of the premises of the Agile Manifesto is responding to change rather than following a plan. So the question is kind of interesting. How do we plan for regression testing? How do you plan for anything in a world where you don't know what's coming next? I think one thing you do is you save time by reducing your emphasis on planning and increasing your emphasis on responding to what actually needs to be done right now. I'm not sure if that answers your question in a way that's helpful to you, so if you'd like to provide a follow-up or give me a little bit more context, a little bit more detail on the kinds of things that you're asking about, you can either do that right here, right now, or you can drop me a line.
Okay, thank you, Michael. We have another question from Rachel Warrington. If we are using exploratory testing for regression testing, how can we measure and understand our coverage?
Oh, okay. Well, let me turn that question around and ask, if you're not using exploratory testing, and if you're using, say, only scripted testing, how do you explain and understand your coverage? Oh, you see, the trouble is that people seem to assume that just because we can account for what we've done in terms of a list of tests that we've executed, then we've performed good coverage. Well, that's not the case. In fact, we need, as testers, to be able to describe coverage in any domain of testing that we're doing. I think what you're talking about, Rachel, the question that you're asking is, how do I record and report on exploratory testing? And there are at least, well, there's actually dozens of ways I can think about doing that. Two large-scale ways of doing that are with session-based test management or thread-based test management, where we simply give an account of what we've tested and where we've tested. That account can be in the form of a comparison against a requirements document, one of my least favorite ways. It can be a spreadsheet in which we can not only have a list of tests that we've performed, but we can also turn that into a table of tests that we've performed against coverage areas that we've touched. We can use the concept of the mind map, which is becoming increasingly popular amongst the folks that I'm working with, to illustrate the various dimensions of coverage. My favorite way of explaining and accounting for my test coverage, though, is to use a mind map based around a structure that's found in the heuristic test strategy model, and that is the product elements structure. We break our models of the product down into structure, function, data, interfaces, platform, operations, and time. And we account for our testing based on the amount of focus that we've given to those conceptual areas. Another way that we can handle testing is through the concept of functional areas of the product and how much time we spent on each one, such that we give a sort of a ordinal scale report on how much time we spent on a given feature area of the product, where 1 is smoke and sanity level testing, where 2 is the common, the core, the critical, the ordinary, the everyday, the usual stuff, the stuff that has to work, and where level 3 is the complex, the harsh, the challenging, the extreme, the exceptional. So to me, accounting for coverage in using an exploratory approach is no different from accounting for coverage using a more scripted approach. My experience is that in the exploratory approach, we identify where we're going to get coverage. In the scripted approach, we're dealing with a model that we've already designed. There are 3 articles that I wrote for Better Software magazine on the coverage issue. And if you would be so good as to drop me a line, I'd be delighted to send references to those articles for you.
Thank you, Michael. We have quite a few questions. We might not get to them all, but let's keep going for the moment. We have one from Richard Bradshaw. So when should we do regression testing? At the end of the sprint, or alongside sprint testing, or before a release?
I think one good way to think about this is, isn't all testing regression testing? I mean, aren't we involved in a search for problems? And if we're involved in a search for problems, then a search for problems associated with regression is in scope. I think we can do a testing focused on things that might have backslid any old time we like, all the time. I sometimes, as I was preparing this presentation, I toyed with the idea of asking, is there any point to differentiating between regression testing and any other form of testing? And it was really only when I thought about Karen Johnson's list of heuristics. Those are heuristics that are strongly focused on regression problems, but if you look at them, they're focused on other kinds of problems too. So I sometimes wonder if regression testing is even a particularly helpful kind of concept. After all, a new problem is a regression problem that we haven't got around to not finding yet. There's whether we backslid or not is dependent on your perspective. Gee, we weren't perfect to start with, so I guess we've regressed. So I think if we always test, we'll always be doing some degree of regression testing. If we believe that there's a high risk associated with change, then maybe we can lean our heuristics more in the direction of that change.
Okay, Michael, let's take one from Ruud Cox. So Ruud Cox is asking, in your presentation, you focus on regression of the product due to changes to the product. But what if the environment changes? For example, competition has a new version of their product. The value of your product might regress compared to that product. Would you count that as regression of the product?
Well, again, that's one of those things where it's what did somebody call it? The philosophers sometimes call this a distinction that doesn't make a difference. In a sense, I would ask, who cares? If some component that we depend on, or something in the operating system, something in the platform that comes along, I really don't care about classifying it as a regression problem. It's a problem, and we've got to deal with it. So I'm not sure, I mean, this is just me, but I'm not sure making a distinction there would be terribly helpful. We got a problem, we got to deal with it. Next question.
Okay, Jean-Paul Warwick asks, is a check that verifies behavior of a complex model and of which the result can only be judged by a human still a check, or should we call it a test?
A check by definition doesn't verify anything, first of all. It only produces a bit. It is, I think, probably more helpful to think of it as an assertion. But the distinguishing factor is, a check might be an element of a test, but the distinguishing factor is, do you need a human to make the check decidable? If you need a human, then it's not a check anymore, it's a test. At the same time, we're checking all the time as we go along without necessarily really noticing it. A check is, it doesn't necessarily have to be run by a machine, but at least in theory could be. But the basic idea is if we require a human to make a judgment, then it's a check. Now, of course, there's something else that goes along with that, which is that even a check requires interpretation in order to have any value. it's very easy for us, and this is one of the reasons that I brought the distinction up, it's very easy for us when all our tests are running green to go to sleep and to say, oh, since all the checks are passing, the product must be good. Well, that is why testing dominates checking. That's why checking is only a component of testing. Checking is not testing in and of itself. Although you could choose to go to sleep and call it testing, but I prefer not to do that myself.
We have another question, Michael, for you from Jason Kowaluk. What's the ideal ratio between check and test for regression?
Somewhere between 0 to 1 and 1 to 0. There's no, it's not an answerable, or it's not a question I can answer in a helpful way. Your context determines your choices, and both of those things change over time. What I would do for that question, Jason, because James and I both encounter these kinds of questions all the time, and James wrote a blog post that sort of covers that issue. It's the way to find that blog post is to look for the words, "What size unicorn should I wear?" in a Google search. And you know, I want to underscore this. What if I told you that the answer were 3 to 1, or 1 to 3, or 20 to 1, or 20 to 3? It's not. I don't think it's a helpful thing for me to say. Is it how many nails should you use to build a house? Well, you might not want to use nails at all. You might want to use screws. I'd recommend really strongly that you look up that post, because it tries to answer questions like that in a way that is helpful, but that underscores the fact that the question really doesn't have a good answer, I'm afraid.
Okay, Michael, I think we'll have to leave it there. Now, if anybody didn't get their question answered, we will send those questions to Michael, and we will put the answers on the EuroSTAR blog within hopefully a week. So just before I go and leave you, I'd just like to remind everybody that this week is our early bird deadline for the conference. So if you'd like to see Michael at EuroSTAR, he's doing a tutorial and a talk. You can make some great savings if you book before Friday. So it's probably, if you're interested, it's worth taking a look at the website, and we also have some good discounts for groups. And then just one more thing before I leave you go. On the Thursday after our last webinar, we will have a chat session for all attendees, and you can come here to discuss your opinions, what you learned, and share your own kind of experiences. And everybody who attends that chat session will be entered into in a free conference place to EuroSTAR 2012. So if you can make it, we will email you the link on the Thursday after the last webinar, and some of the speakers will make appearances there as well. So I'd like to thank you again, Michael. That was a really great session. I think everybody thoroughly enjoyed it. This webinar is now over. Have a lovely day. Thank you.
Thanks, Miriam. Thanks all.
Thank you.